as you said, I have been visiting since the beginning of the 1980s. I have worked very closely with Brazilian colleagues in works which have been recognized by the Nobel Prize, so I want to say it here. And one of my PhD students has now big responsibilities in this university, Paulo Nussensweig. So I'm very glad to be here again.
You undertook to do something which was thought to be impossible, which was to manipulate a single photon and to observe it in its different quantum states. So, basic question, why did you begin to do something that was basically impossible?
No, when I started a long time ago, it was when we did experiment on a huge number of particles. We had billions of atoms in a cell interacting with billions and billions of photons in light beams. And then I realized that by using new technologies, it was possible to increase the sensitivity so that we would be able to measure things happening with fewer and fewer particles. And of course, the holy grail was to reach the point where we would have a single atom interacting with a single photon. And this was made possible by developments in technology, especially by having more and more sophisticated lasers. In fact, I was very lucky when I started my career that the laser had just been invented. And it was quite clear that that the laser would certainly open new ways to do research, but we had no idea of how well this would happen, how far we would go with lasers. And as you said, also what was challenging us is the fact that the founding fathers of quantum physics, people like Bohr, Einstein, and Schrödinger, were imagining this kind of experiments, but they were at the same time they were thinking that they would be forever impossible. And when you do this experiment with single particles, you unveil directly the strange features of quantum physics, like state superposition, entanglement, which these people, and quantum jumps, for instance, that the founding fathers had discovered, but thought that they would never be seen directly because of the fact that by working on statistical ensembles, this effect will be forever hidden from us. And the fact that we are able to discover, to unveil this mysterious world was really fascinating and was the deep reason why we worked in this direction.
So as a youngster getting into the field of quantum optics, did you imagine this endpoint, or was it
not at all? Not at all. I was given first. I learned about the laws of quantum physics, which I found fascinating. I was lucky to be in a lab with really charismatic teachers, which unveiled these laws to us, and they gave me a lab for my PhD. I had a cell which contained a huge number of atoms, as I said, and I was free to explore with that. And I understood that in this cell, in spite of the fact that there was a huge number of atoms, each of them was reacting according to the quantum laws, and I wanted to see that. You know, there is a beautiful, this is expressed in a beautiful way by Edward Purcell, who was the Nobel Prize winner for NMR. He invented nuclear magnetic resonance, which describes the properties of magnetic moments. Each atom in our body, each hydrogen atom carries a small magnet. And when this magnet rotates in the magnetic field, for example, magnetic field of the Earth, it emits microwaves. And the guy who recognized that and was able to use this interaction to start a field called NMR was Ed Purcell and Felix Bloch. And in his Nobel lecture, Purcell says that since he made this discovery, each time he goes out and he sees on his doorstep a big heap of snow, he reflects upon the fact that in this pile of snow, each proton is slowly rotating and emitting microwaves. And he says that this is a kind of recognition which is a reward of a researcher, to understand that something which was not understood before happens, and that he just has discovered this for the world to know, even before any application. And of course, there have been a lot of application of this thing. So at my level, I feel the same thing, that to be able to observe these phenomena which were hidden because of lack of technology before, and to observe this for the first time, and to dream about the fact that it might be useful for something, is a big reward for a scientist.
You mentioned being free in the lab when you were young to explore.
Yeah.
How important is freedom? Was freedom to you, and is freedom in general in research?
It's ideal to be free, and this was the case. I think this was more the case in the past, because we could do this kind of experiment with less resources. It costs less money than it is now, and the research was at the time more bottom up than top down. And now there is a tendency to organize research according to programs. For example, there are big programs now in quantum information science, quantum technologies, and these programs are directed from the top down. And it put a lot of constraints to the people who are doing this research. You have to propose things, you have to promise results, and this is not the way research really works. What you do is that you explore things because you are curious, and then the applications come very often from unexpected directions. And I think that policymakers should take more care of that, and understand that you have to support research by trying to build the best conditions for bottom-up research to spring out, and not try to impose the research from top down. It's rather difficult to achieve, but I think it's very important.
It's very challenging, as you say, given how expensive it all is now.
Yes.
But yeah. What would you say would be the key thing for a young researcher, not just a physicist, to bear in mind as they embark on their career in choosing questions, in finding a place for themselves?
It depends, of course, on the personality of each researcher, so you can only say very general things. I think you have to, of course, they have to be curious, and they have to try to focus to recognize a field of research which interests them very much. In my case, it was laser physics, because the laser had just been invented, and there was so much promises that the laser could achieve that I went in this direction. But today, there are other fields, of course, in which you have this kind of promises. It also depends on the personality, as I said. I listened carefully to what Maybrit said before, and I can share that we are working in small labs. We are working with groups of a few, let's say 10, 15 researchers working together. And in this case, you can build a kind of synergy between the people, young and senior people. You can exchange, you can support each other. I think humor is very important, because in the research days, you have a lot of drawbacks, you have a lot of failure. And if you are not supported by your colleagues working together and trying to make fun of these problems, life becomes more difficult. So this is one aspect. There are other big projects which involve a huge number of researchers. I am talking about particle physics, I'm talking about astrophysics, which works in big. Yeah. So if you want to get into this, you need to have the right state of mind, accept the idea that you will be working in big groups, and try to find your niche, your particular interest in these big groups. This is quite different. You have to be ready also for interdisciplinary work, as was said before, because now research involves a lot of knowledge in different areas. The connection with mathematics is important. For a physicist, you cannot have all the knowledge in mathematics that you would need, so you have to be able to surround yourself with good mathematicians. This was the case of very famous people. Einstein, when he discovered the general theory of relativity, lacked the knowledge in math. Like, for example, geometries in curved space is something that he had no idea about, and he was able to find colleagues who explain to him this kind of math. And this is very important now.
That does seem very important, having the confidence to ask for help, assistance when
Yes.
you need it.
Yes.
Again, not something that necessarily comes naturally
Yeah.
because you're taught
Yeah.
to
Yeah.
be self-reliant and
Yeah, I can give you an example from my own research. Now, since we are able to manipulate single atoms, now we can organize these single atoms in arrays, and we can simulate what happens in condensed matter physics, what happens when a huge number of atoms which are located at well-defined position interact with each other. And these simulators might help us to discover new phases of matter, which might be very important for technology. For instance, superconducting at room temperature might one day come from this kind of research. But for that, you need to have a lot of knowledge in quantum phases of matter, which is a big field in theoretical physics, which gave rise to many Nobel Prizes in the past. But for that, there is a knowledge in mathematics, in topology, for instance, that I don't have. And in order to understand what would be useful and what kind of experiments we have to do, we have to interact with mathematicians and with specialists in theoretical condensed matter physics. So it's a very interesting and very stimulating area, but it requires cooperation.
Thank you. Okay, we're going to go to questions, but just as we do, I want to ask you, we've called this session the art of being a scientist. Do you like that term? Do you think,
yes.
Do you think it works? Is there an art to being a scientist?
I like the connection that you make between art and science. Of course, I think art and science share a lot of things in common. You need imagination, you need some kind of intuition, you need creativity, and so, but the creativity and the intuition come in different forms for art and science. And I think it opens the mind of a scientist if he has some interest in topics outside science, some art and history of science, history of art is very interesting because they converge. It's very interesting to realize that the great discoveries in science and the great revolutions in art came very often together. If you think about the Italian Renaissance or what happened in Germany and in Europe at the turn of the 20th century, there was a kind of evolution in art and science which went together and which have certainly influenced great scientists like Einstein, Niels Bohr, and in the past people like Galileo. And so it's quite, I think it's very interesting, very important.
Thank you. Well, we'll talk more about the connection between art and science right at the end of this morning. Question right at the back there. Can I go to this? Sorry, I don't know where the microphone is. There, right at the back on the a bit further. Yeah, there. That's it. Please. Thank you. And then you. Please.
Well, first, thank you very much for the lecture. My question, as you cited, you really know a lot of Brazil. You come here and you have even research partners that are Brazilian. So my question was more of, and as you cited also about history of science, this question was, why do you think there is no Brazilian laureates? Like we have Argentinian laureates. Why do you think that makes people pursue these and maybe not pursuing, but achieving this goal, which is, I think, one of the biggest goals of scientists in natural sciences. So thank you very much for the lecture.
Thank you.
I think it's a tough question. I think now in modern science, you need a lot of resources, and so it's difficult for some labs to compete with the resources that you can get in labs in Europe or in the United States, which have had a long experience, a long tradition in fundamental research and in science. But I'm sure that it will come because Brazil has, in terms of bright minds and bright young minds, I think you have all what you need. And I must add that you have a lot of resources that you don't exploit, because I think the education system by itself at the lower levels and universities is still lacking the qualities that it would need to give equal opportunities and equal chances to all the young people, all the young minds that you have in this country and also in other Latin American countries. Now, why, for example, Argentina has a few Nobel Prizes, not Brazil? I think it's just a question of chance. Since we are dealing with small numbers, to make statistics is difficult, but I'm sure that Brazil deserves at least as much as Nobel Prize as other countries of this kind. I also heard when discussing with colleagues that in fact you have one in physiology and medicine, but he left Brazil to go to England in the beginning of the 1960s. And so, but this gives me the opportunity to add that, it's maybe I should not say that here, especially because we come here invited by the Nobel Foundation, that you should not, the Nobel Prize should not be a criterion for that. It's like, it's not a good criterion to count the number of publications in Nature and Science, and it's not a good criterion to count the number of Nobel Prizes, because there is a matter of luck to win a Nobel Prize, a matter of fact that you come at the right condition at the right time. And I was lucky to get it, but I'm very well aware of the fact that I have a lot of colleagues in the world who are doing the same kind of research and who did not have that luck, because it turned out that you give only at most 3 Nobel Prizes in a given area. In my case, I always regretted the fact that I could not share it with the people who have been working with me during all their career, Jean-Michel Raymond and Michel Brune. And if you want to extend that more, the work that I did with Luis Davidovich and Nissim Zaguri in Brazil was the seed for the experiment that we did a few years later. And in fact, the Nobel Prize should have recognized all this team, but it's impossible because of the rules of the Nobel Prize. So the Nobel Prize should not be the only criterion. I think that what you need to do is to improve the education at a lower level. This is the kind of question I also get when I am in China. They say, why don't we get? And then this relates to the question you ask about the connection between art and science. What I tell them is that, but you get Nobel Prizes. The only point is that you don't like them. Like peace Nobel Prizes, we were in jail and we died in jail. And literature Nobel Prize, they did not like because they were critical of the system. And I think so it was a kind of joke, as I did not like it, but I think it's more than a joke. It reflects the fact that if you want to have good science, you need to have free thinking and a free world. The academic world must be a free world, and this is one advantage you have here that we have in democratic countries, and it's a big advantage. And if I want to be a little bit cynical, this is an advantage that we have because we don't have as much money as China is putting into research. If they have the freedom and all the money that they have, they would overwhelm us with their research. And so they have a kind of string attached to them, which prevents them to develop all that they could have. And we should do that in our countries.
Thank you very much, Serge. Thank you for being bold enough to ask the question, because the answer was absolutely fascinating. Thank you. We have very little time, but this person, very quick question, very quick answer, and then we finish.
First off, thank you for the lecture. So you mentioned how research nowadays is often done from the top to the bottom. And for a fledgling researcher that how do I say this? That wants to do that sort of research that's more from the bottom to the top, and can be kind of hard for even the environment of the environment of the academic field nowadays. What advice would you give someone like that? What should we do to pursue that kind of research? Despite how
Okay. So thank you very much for the question. But the question used up our time. So it's a very good question. What advice do you have for people who want to go from the bottom, not work within a top-down environment. You've got no time, so we can come back to it in the responsibilities thing, or very quick.
I think the question is more to the policymakers. You have to develop the conditions which allow the research to go from the bottom up, and for that, the research the environment should give money, should make the system such that the money could be given to bright young people and give them a few years to prove that they are able to do productive research. This is how it works in very successful institutes in United States, in Switzerland, in Israel. They give this opportunity to young people. They give them money, and after a few years, of course, you have to evaluate. Some of them will get tenure, others not. So it's a system which involves some risk for the young people, but the risk goes with the trust they are given at the beginning to prove themselves. In other countries, and I am not very happy to say it's the case in France, the system does not work that way. You hire young people, you give them tenure from the beginning, but you don't give them the money they should have and the support they should have to be able to prove themselves. And from the beginning, you ask them to apply for research grants, which come from the top. And I think it's not ideal. I think you have to combine systems which give opportunities to young people to start from the bottom and then to support them from the top later on.
Thank you very much indeed. It's a very important topic, and we will talk about it some more when you're all together. Thank you very much, Serge. Now you stay there.
Yes.